We're going to do a case study on recommissioning an industrial gas chiller. I have to say that when I read the solicitation for commissioning a chiller on the North Slope of Alaska, I thought, wow, cool. I didn't know they had any chillers up there. Because, of course, I was thinking of an HVAC chiller making chilled water. This is a different kind of machinery. This is a chiller that is more like an air dryer. It chills the natural gas coming out of the gas field to to 40 below zero so that the impurities can condense and be separated from the pure gas. Melissa Bynum is the owner, and I'm the commissioning consultant. This case study examines the restarting and recommissioning of this equipment. It validates the building commissioning process, because this is not a building. This is a single piece of equipment, industrial equipment in the gas field. The commissioning led to a new OPR, operational hazard analysis, design and review, installation, verification, testing, as well as the planning, documentation, and training that all goes along with a successful project. So these are all the things that you're probably familiar with from buildings, but we did it on a single piece of equipment. Learning objectives. I'd like to learn the difference between startup and commissioning. Number two, hopefully you will learn that using all the steps in the commissioning process is important and not cutting corners or leaving something out. I want you to hopefully get from this that you can apply the building commissioning processes to a non-building application. That's the whole purpose of this presentation. And understand that if you don't get it in the project specifications, it's not going to happen. And that was the case of with the first iteration of the commissioning when the project was brand new. So, great. My light up here, is ruining my slide. So, what that was supposed to be was, here's a mountain range. I took this picture when I was flying from Anchorage to Fairbanks at about 20,000 feet. And I noticed that down here is a mountain range. And I thought, wow, somebody standing down there would look up at that mountain range, about the size of a big ski mountain in Vermont or something like that, and they go, man, that's a really cool mountain. And if they stopped their inquiry there, they would miss the real story. This is Denali, the tallest mountain in North America. This is 4 Acre, the second tallest one in North America. And because there's a cloud bank right here, they wouldn't be able to see past what was right in the most obvious superficial part was this little foothill. They would have missed the whole story. So in today's presentation, we're going to talk about who we are. We're the owner and the consultant. We're going to talk about, what is this thing? Why is the fact that it happened in Alaska meaningful? Why not? What's the big deal about being in Alaska? And what is this natural gas chiller? We're going to hear the owner's perspective on why the project needed to be recommissioned. We're going to compare the original commissioning to the recommissioning that we did. So it's like a compare and contrast. We had some system challenges when we got into this. We didn't really know what to expect. I think like a lot of recommissioning or existing building commissioning, if you want to think of it that way, you're going to stumble across some stuff that you don't understand. You're going to maybe find some new requirements that weren't addressed in the beginning, and you're going to have to deal with them. So that happened to us too. And then, of course, at the end, we're going to talk about what's next. So.
Good morning. My name is Melissa Bynum. I'm a program manager for North Slope Borough in Borough, Alaska. And I've lived in Borough for about 23 years. I'm originally from California. So through a bid solicitation process, we went ahead and hired Coffman Engineering to come in and take a look at what our chiller was doing and why it wasn't working like we wanted it to.
And I'm Walter Hines. I was the commissioning consultant. Obviously, that picture was not taken in Borough. As a consultant, I developed the approach, I facilitated the OPR, I developed the commissioning plan, and I was there for all of the field activities. Also on the commissioning team, we had mechanical and electrical engineers that served as technical consultants, so we could get all that right. We had the manufacturer's engineer to give us product support, and he was quite technically astute also. We had the gas field operators. The way this works is the North Slope Borough owns the land where the gas field is, and they hire a contractor to run the gas field. So these are the users. These are the folks that deal with the gas every day and have to get it to market safely and in its pure form. We had subcontractors. A refrigeration contractor came in and did some repairs and some upgrades to the equipment itself. And a PLC integrator, for those who don't know, PLC is a programmable logic controller. It's a little computer chip that is programmable and allows, that actually runs the equipment automatically. You could call that the DDC component. The PLC integrator actually swapped out the old PLC for a brand new one. And the Alaska factor.
Okay, I guess it's my turn. So, like I said, my name is Melissa, and I'm the program manager for this project. I was handed this project, and about...
It's the down arrow.
The down arrow, okay, thank you.
Okay.
So, this project, the chiller hadn't been working for about 5 years. So it was my job to hire somebody to come in and take a look at it and see what was going on. So the Alaska factor, this picture is a picture of Borough. And it's a picture of Borough in the summertime. We're surrounded by water. So, the down arrow, here we go. All right, so the Alaska factor. Borough is now known as Uktiavik. Don't ask me to spell it unless I look at it. We have recently changed our name to a native name. And we're also the most northern city in the United States. So I always win the prize of wherever I go. Who traveled the farthest? It's me, usually, always. So we're located 320 miles above the Arctic Circle. Little known fact, nothing grows above the Arctic Circle. So if you've ever been to the state of Alaska, you've seen big mountains, you've seen big trees, you've seen it's nice and green and beautiful. Not here. So it's all flat. We have all tundra, and nothing grows. We have no trees, nothing like that. So it's all flat and vast wilderness for miles and miles and miles. So our population is quite big for the slope. We have just under 5,000 people that live in Borough. Here's a little comparison. The North Slope is compared to the Gulf Coast, and I'll show you exactly why in just a minute. So this is the North Slope. And the North Slope Borough manages all of these villages. So bear with me, I'm not left-handed, so I'm trying to hold the mic and point. So all of our villages, we got Point Hope, Point Lay, Wainwright, Axook, Nuiqsut, Borough. Go to the next slide. There it is. Anatuvik Pass, Kaktovik, those are all of our villages that the North Slope Borough manages. Prudhoe Bay, we don't consider one of our villages, even though we do have offices there. We have landfill, we maintain the water and sewer and stuff there. It's not considered one of our villages. If anybody's ever seen Ice Road Truckers, yeah, so there is only one road that goes to the North Slope, and that is it, from Fairbanks along the Hallwa Road up to Prudhoe Bay. Other than that, ConocoPhillips in the wintertime will build an ice road to the village of Nuiqsut to maintain their pipeline. Other than that, There are no roads to any of these points. So, logistically, trying to get materials, freight, equipment into our villages, and particularly Borough, is quite challenging. How do you get something to these points if you just can't, truck it up? It's really hard. It's very challenging. In the wintertime, we have in the wintertime and in the summertime, we have freight flown up all the time. In the summer, we have to barge it up. So you have to be pretty organized. You can't just go buy a piece of equipment and say, hey, we need to take it up to Borough today. No, it doesn't work that way. If you're going to put it on the barge, you need to plan ahead. You need to get it to the dock by mid-May. Then you got to get it on the barge, and then the barge goes through the inlet passage, goes up through Point Hope, Wainwright, Borough. We see it about late August, goes over to Koktovik, and then we can backhaul everything else. Not easy. It's even more difficult for the smaller communities. These smaller communities are only accessible by small planes. So we're talking caravans, we're talking 1900 Beechcrafts, very small planes. So freight will fly up to Borough, and then from there we can fly it out to the smaller villages. I love apples. I have to pay $4.99 a pound for apples because we're so far. Bananas, $9.99. If you have children, oh Lord, help you. If you have milk, you need to buy milk, $10 a gallon. Diapers, oh goodness. We're talking like a 15-pack, easily $30. Eggs, $7. Chips, $10. Ben & Jerry's, pint of ice cream, $10. There are times when the weather is so bad that freight cannot come in. And so we have been bare. No eggs, no milk, produce, empty aisles. Yeah, it's challenging. Sometimes it's not fun. But we are there to help the community and to get things rolling. So the next, we were talking about that 640 miles compared to the Gulf Coast. There you can see. It's pretty wide. So the North Slope Borough controls all of the villages, including Anatuvik Pass. So the North Slope Borough, we run emergency services. We've got the police department, we've got the fire department, we have public works, we have health department, senior services. We also run landfills, airports. So we control all of that. We maintain all of that for the North Slope. And the North Slope Borough is about 94,000 square miles across. So in our climate can range anywhere in the winter from 40 to 30 below. And in the summertime, it can range anywhere from 40 to 70 above. We have 8 villages that are included in the North Slope Borough, with the village, the smallest population of 200. So you can see right now, just trying to get anything fixed here is pretty challenging. We're also known as the land of the midnight sun. So in the summertime, we have 24 hours of sunlight, which means in the wintertime, we have 24 hours of darkness. Sun last sets on November 18th and then doesn't come up for 65 days, which makes a very, very long winter. So when the sun does start to come back up, it starts coming back up at about 10 or 15, 20 minutes a day, we start gaining sunlight. About this time right now, the end of April, early part of May, we have about 18, 19 hours of sunlight. By the end of May, we'll have 24 hours of sunlight. By the end of August, the sun will start going down again, and we will lose 10, 20 minutes a day. We have wildlife. We have polar bears. They are cute, they are cuddly, and they will eat you. So this is a picture of our football field, graciously donated by Kathy Parks from Florida. So we do have a football team. And this polar bear was photographed wandering around the football stadium. not much of a stadium, but the football field. And this was during the summer months in the late fall. We also have caribou. And we have all kinds of birds. Borough, for some reason, has birds from all over the world that come up there. So in the summertime, it's a huge birding population that comes in. So, misconception, we don't all live in igloos. We actually live in real houses. This is actually my house. It's a very tiny house. Someday I will have a regular big house. But not all houses are this small. So we do not build our houses on traditional concrete. We build them on pilings, and that's to help preserve the permafrost. Natural gas is essential to us. We pump that gas out of our gas field. We process it at our local utility company. And in turn, we have heat for our homes, electricity, and we're able to manage our water and sewer plants. So, why did we need to commission this chiller? Well, we had a chiller that hadn't been working for 5 years. Nobody could figure out what was wrong with it. Like I said, I had it handed to me, and I had to figure out what was going on. So it didn't work. We need this chiller to dry out our gas, to process it so that our residents can live. And so, move on. The chiller skid was constructed and installed in 2009. It ran for about a year, and then it stopped. We run it seasonally. We only need it to actually run during the summer months. That's when we need to cool down the gas. In the wintertime, it's so cold, we don't really need to do that. So we ran it seasonally, and it ran for 1 season. And then it started to fail. And unfortunately, the previous operators that ran the gas field before the ones we have now were not quite sure what was going on and what to do about it. So they ended up bypassing this chiller skid into our primary gas handling facility. Our community is growing. We have more demand for fuel, so we really need for this chiller to work. Because it has not been working, we've had a lot of maintenance issues. So this is essential for us to get this working. So through a bid and solicitation process, we were able to get Coffman Engineered on board. They went through and they did their analysis. They found that we had missing lubricant components. These key components were crucial for the chiller skid to run. And you can see this, this picture is a section of our pipeline. This is in town. So not only did we need the chiller skid to run properly, we also needed to collect that data and transmit it back to our operator center so our operators can take a look at it. So by doing this, we installed a PLC, an HMI, and then eventually we did program our SCADA system into this. So now, not only does our chiller work, and now we also have the opportunity to work it in the winter and in the summer, we also can collect the data we need. And right now, I'm going to go ahead and turn this back over to Walter because he's going to go into the technical details of the chiller skid. Thank you.
So this is it. This is the chiller. It has 4 compressors, 4 Bitzer tandem compressors. This is a Bitzer tandem compressor. It actually has 2 motors and 2 compressor heads on a single body. So when you think about it, that's 4 times 2 is actually 8 compressors, and every compressor has unloaders on the cylinder heads, so that there's multiple stages of loading and unloading of this equipment. Behind, you can't really see. Back in here, there are shell and tube heat exchangers. Those are the evaporators. They're rated for 5,000 psi, and then all this copper piping up here are the multiple refrigeration circuits that go outside to the air-cooled condenser. So this is a typical refrigeration cycle. The refrigerant starts here, it gets compressed, it goes clockwise through the air-cooled condenser and cools off. Then it goes through a thermal expansion valve and through the evaporator, which is that shell and tube heat exchanger I mentioned. And the way this works is that the natural gas goes through the evaporator and it gets chilled as it goes. The chiller skid is actually 4 separate compressors and refrigeration circuits. So the package air-cooled condenser is one condenser outside with 4 refrigeration circuits in it. The skid has 4 compressors and 4 evaporators in it. And the natural gas sequentially goes through them in series, so it gets colder and colder as it goes. There's one more heat exchanger on this, one more evaporator. That's an economizer evaporator, so they take the chilled natural gas and cross it with the incoming gas, and it pre-cools the incoming gas. So the initial commissioning structure and plan was really kind of scant. There weren't much in the way of specifications for the inspecting and the testing. There really wasn't any specification for training, although the manufacturer did give training to that first set of operators. Unfortunately, it got lost over the years. And there was no specification for good quality O&M manuals or system manuals. They did get a manual for the compressors themselves, but as far as the whole system, how it works, how it should be operated, none of that was available. When we took over the job, we really had to do a lot of searching to find out, what is this thing and what does the owner really want.
Yeah, and I could tell you one thing, the owner did not know what it needed or what it really wanted. We just knew the thing didn't work.
Okay, then the pre-functional, the initial pre-functional process, there was some factory witness testing, but it was incomplete. The report from the factory witness testing was that one compressor was operating and there was no load. So that really didn't really do much for the pre-functional exams. There was a factory checkout report when the system was shipped, and it said how many pounds of refrigerant were in it, and a few other just basic facts. And very little of all this was recorded. This is the factory checkout sheet for one of the chillers. It talks about, it's a 463 phase. It talks about that it had some NEMA 4X electronics, that it took so many pounds of refrigerant, and there's page 2, and that's everything. So that was what we got. There was no pre-functional checkout of the installation itself. The initial commissioning functional testing was better described as a startup. Yes, they did start it. They did get it running. They did show the operators how to use it, and then they left. They had a short run time. They did almost no benchmarking, so there really isn't a record of what the performance of the equipment was the day it was brand new and installed. And they just had really poor records. So this is what we were up against when we walked into this project to commission this HVAC chiller. Oh wait, they don't have those in Borough. This is the letter that was the documentation of the job complete. It's a letter from the manufacturer that says, yeah, it works. We started it at this time. We ran it for 3 hours. We got the temperature down to 42 below, and we're leaving.
They were on the next plane.
They were on the next plane, yeah. The technicians that were working there did take some notes, and we do have those notes, but between those 2 pages, that's 100% of the documentation of the functional testing and the checkout of this equipment. So those are the original functional checkout sheets. By the way, in the gas field, in the oil fields of Alaska, functional performance testing is called FCO, functional checkout. It's just the word they use. They do have some pretty sophisticated procedures on a lot of machinery and systems up there. So the recommissioning. First of all, I'd like to point out this is a photograph of the site. Over here is a building that has some manifolds of piping and valves. There are 3 different gas fields that converge right here, and they first go into this building here. Then they're piped over to this building. This is the primary gas handling facility. In there you have some pressure regulators, you have an electric room to control a bunch of equipment, you have a boiler room because they do reheat the gas at times. And then from here, it's at 900 psi, it is knocked down to 300 psi at a pressure regulator, and it goes to the gas chiller facility. That's where the chiller is installed. We had to scope this project. Like Melissa said, they didn't really know what they wanted. We didn't really know what they had, or there was some hearsay and some rumor of memory of what it used to be or should have been, but we didn't have a good idea of where to go with that. So the first thing we did was we start asking questions and doing some investigations. We determined it needed some major refrigeration upgrades. It was low on pressure. It couldn't keep the oil in the crankcase. And those two things alone were just fatal to operating the refrigeration. It also needed a complete PLC replacement. The PLC that came with it was an obsolete Siemens product. It had already lost its factory support. It was programmed in a different language. The gas field had standardized on Allen Bradley anyway. And they had a lot of trained PLC operators or programmers that could work with the Allen Bradley. It also didn't communicate the data as they wanted, and they didn't have access to the native programming, so they couldn't do any tweaking or adjusting or modifying of the programming. So the PLC had to go, and that was a huge part of the job. The commissioning authority represented the owner in developing the RFPs. And then also evaluating the proposals and selecting the contractors to do the work. The OPR started out with me asking a whole bunch of annoying questions, and they said, well, don't you know this already? And I said, well, I could guess, but I wouldn't be answering it the way you would answer it. So for the first thing we had to find was, what's the real set point? The equipment was designed to make the gas 40 below zero, so that was the design point. But is 40 like it never gets warmer than 40, or is that the point where the equipment can start unloading? The operators did a few practice runs at different temperatures and decided that they could run the thing between 35 and 40 below. That was really helpful because a machine that's made to run to 40 has a hard time getting all the way to 45 below. But it's pretty easy for it to get to 35 below and then modulate between 35 and 40. Here's a picture, a screenshot of the HMI, the human machine interface that's on the control panel. You'll notice right here it's entering the system at 7 degrees. And then there's a little bit of residual cooling as it's going through that first economizer heat exchanger. It enters the first compressor at 10 below. It exits at 26 below. It enters the next one at 26 below and goes to 28 below, then 28 below to 32 below, and then 32, in this case, to 41 below. Then you'll notice that as it leaves, it goes through the economizer and it's warmed up 22 degrees to 19 below. It's too bad that light is shining right on the screen there. It makes it a little bit hard to read. So that 22 degrees from 41 below to 19 below actually got injected into here before it got to 7. So it was really 29 degrees when it entered the system, and it was 19 below when it left the system and went to market. We had to determine what is the really seasonal operation. Is it only in the summer, or when the sun is shining? And by the way, that's what makes the gas need the chiller, is because the gas shining on that 17-mile pipeline has a lot of solar gain, and it keeps the impurities suspended in the gas. So, summer, winter, we asked the question, and the operator said, well, we'd like to be able to run the thing in the winter if we have to. Now, that's probably not during the dark months, but definitely it could be in October, and it definitely could be in March. So here's a picture of us trying to get the system running in March. We went up there. The thing was caked with ice and snow. We tarped it. We put a heat truck on it. We leaned ladders against it to keep the tarp from blowing away. And by the way, this was the worst picture I could find. There is a much better picture of the air-cooled condenser, but you've all seen one. It's just an air-cooled condenser. The difference with this one is that it does have 4 completely separate refrigeration circuits in it. The design had to be modified so that they could run this thing in the winter, and the operators are going to be putting a shelter over it. The PLC shortfalls. I kind of outlined them before. It was a compatibility with what was standardized on their other operations. It was data compatibility. It was obsolescence in the chip itself, and it was the data and the native code. They didn't have access to the native code, so they couldn't do any tweaking of the programming. This is a picture of the new HMI. On the new control panel. It's a touch screen and it's explosion proof. So we had to examine the hazards. This is a class 1 Div 2 facility. What that means is that it's not normally dangerous or explosive atmosphere, but it could be. So everything has to be able to not start an explosion if there's ever a gas leak. This is the HVAC mechanical room. It's adjacent to the chiller room, and this is not a classified environment. So what we have is, which one? What we have is an air handler, a gas-fired air handler here. We have some exhaust fans. Everything's controlled with fire smoke dampers, I should say. There's a small PLC right here, which controls the operations of these. It receives signals from the chiller and from the gas atmosphere monitor in the chiller room, so it will know when to shut down. There's a whole sequence of operations that it was supposed to undergo under different scenarios. We did a kind of a matrix that had every piece of equipment on one side and any possible condition on the other side, and then there were notes and X's and ons and offs and other information in the matrix saying what the system did. When we got there, we found out that because of the poor training, that things had been overridden, and some of the equipment was operating in reverse of what it was supposed to do, so it was actually making things worse in the case of an explosive atmosphere instead of better. We got that changed, and we included that in some of our final checkout. Then finally, the commissioning plan went through the process, the who, what, when, where, why, and how of commissioning. So we completely did a narrative of exactly who's going to do what and how we're going to proceed. We issued the pre-functional check sheets, and we created them, and then we issued them. Here's a picture of our refrigeration technician and the manufacturer's rep down on their knees. I think they're charging the refrigerant right here. They spent days crawling around on their hands and knees adjusting the system and getting it to operate at just the right temperatures. If it's too cold, it'll freeze up and you start slugging your compressors. If it's too warm, it's not making the temperatures. And then, of course, there was the programming that had to have each staging and unloading sequencing so that it ran smoothly. They spent days and days doing that. I was really surprised that it took that much. But it's a very complicated piece of equipment. Our pre-functional check sheets had, for each compressor, there was nameplate data, and then there was also a construction check sheet. Then for the refrigeration system itself, there was nameplate data, the pipe, the refrigerant, the flux, the brazing filler metal, all that sort of thing. All the equipment that we added had its nameplate listed, and then there was the construction side of the refrigerant system also. And it went through, let's see, there was a repair on one of the compressors, there was startup, there was closeout. Closeout included all sorts of, what do they call it, chain of custody for hazardous materials. There was a startup record, there was a record of how much refrigerant went in there, all that sort of thing. Next, we did the programmable logic controller replacement. This is the PLC right here. These are terminal strips. Every wire is labeled, nice and neat. Got the battery backup. Before we even started doing the pre-functional checkout on the installation, there was a factory acceptance test. Our electrical engineer met the designer at their shop. They went through a factory checkout of the whole PLC and its control panel. This is one of the things they did. They did a point-to-point checkout. This is the first of 6 pages of ladder diagrams, and they went through and they annotated every single point along here. They're all recorded. Then they had a startup check sheet. There was 3 pages of startup, checking all the IOs. One of the things we added to the project was a oil level detector. This oil level detector had to be Class 1 Div 2 rated. It had to withstand the refrigerant that it was submerged in, well, refrigerant and oil. And it had to, withstand 400 psi and high temperatures. So this was an upgrade to the control system from what it was when we first started the project. Then we issued the functional performance tests. Now, functional performance testing is what I call the fun, easy part of commissioning. Because if you've done all the rest of it, then it's just fun to watch this equipment work the way it's supposed to, and it's kind of fun to push the buttons and have things happen. What you're looking at here, this is the primary gas handling facility, and this green actuator is controlling a 3-way valve from the boilers. When the gas comes in the wintertime at 900 psi and 30 below zero, and then goes through a pressure drop to 300 psi, it drops in temperature quite radically, and it can become so cold that it can freeze up seals and actuators on other control valves. So they have to have a means of reheating the gas. We used that capability to impose artificial loads on the gas. And so when we were doing the functional testing, we tested it clear up to about 75 degrees incoming at full flow. The functional performance tests were about a 15-page test form. It started out by just stating, some of the basics. There's an equipment matrix. It had recording the initial conditions when it started. Then, if you can read the fine print, I don't know if you can, it starts here. It says, raise the entering gas temperature by 10 degrees, state the conditions, and then we recorded all the conditions right here, and then run for 30 minutes, and then raise the temperature another 10 degrees, and do it all over again. We did that in 10-degree steps. I think it was 6 or 7 steps before we got all the way up to 65 degrees or whatever our final temperature was. When we got it to the final temperature, we went through and completed this matrix, doing voltage and current, and then gas leaving temperature, entering and leaving temperatures. The whole time we were able to get the gas flow rate from the operators. They're monitoring that all the time anyway, so that was always annotated in the margins. And let's see. Here's one of the technicians installing the new PLC. Up here is his explosion-proof HMI screen, which is facing outside the door. It's got all the, you saw the one face front of this stuff in here. And then these are all of the sensors and actuators that went out to the original piece of equipment. And he took those same sensors and actuators and terminated them in the new PLC and reused them. The performance test for the PLC was 10 pages long. It was written in a little bit different format. We worked real closely with the PLC integrator to make sure that everything he had in there was on the test so that we could step through it in a logical order. I'm just going to show you a few pages here When it was done, we had to record things like for each tandem compressor, there's eight compressors there, and so on. So there was a little bit of scratching in the margins, but it all got recorded. Then there was a benchmarking table at the end. I think we had 3 pages of benchmarking, and everything got signed. There's a picture of the integrator testing out the new HMI. If you look at this, this is one of the electrical panels, and it is the explosion proof. You can tell by all the bolts and all that. The oil management system that we had to add, now I'm a mechanical engineer, so this was the coolest part for me. What was happening was that the oil would get pumped out with the refrigerant, and it wouldn't return adequately. At some flow rates it was okay, but as the machine was unloading and going up and down in its staging, sometimes that oil would get lost, the crankcase level would drop, you'd get a low-level alarm, and it'd shut down the compressor. And these are the problems that Melissa was saying that the operators had. They couldn't get it to work right, so after the first season, they just gave up on it. What we added were coalescing oil filters for each compressor, each tandem. So there's 4 of these. This coalescing oil filter, the refrigerant, the hot gas comes in the bottom. The oil gets separated out of it, and the gas continues up and out into the system while the oil gets separated out and goes through this tubing up into an oil reservoir. Oil reservoir is at high pressure, and then it goes through a pressure regulator and, over to this float valve on the compressor crankcase. The float valve acts kind of like the float valve in your toilet. When the water level gets too low, it opens up the valve and lets some more oil or water in. Well, it does the same thing with oil. The refrigeration upgrades also included all your basic refrigeration components. There were service valves, there were filters, there were sight glasses, there was a check valve right here. It was a complete refrigeration upgrade. We had to cut into the old piping, install this, and then send the refrigerant back out to the air-cooled condenser like it did before. This is one of the cylinder unloaders. Incidentally, while we were doing some of the test runs, we noticed that the temperature of one of those reservoirs was getting a lot hotter than all the others. And as we went through it, we discovered that a valve in one of the compressors was leaking by. These are reed valves. They're not valves like in an internal combustion engine. So the reed valve was leaking, and that meant that it was pushing a lot more gas and oil into the coalescing system, and that meant it was cycling it all through way too fast. As a result, a change order was written for the refrigeration contractor, and he disassembled one of these heads and replaced the reed valves. Then there was a project closeout. We had to have training. We had to develop the content. We had to engage a videographer and schedule the trainees. Here we have a shot of the training getting started. This is one of the operators right here. Don't be fooled by the overalls and the hands in his pockets. These guys are really sharp. They just wear comfortable clothes. They were there for all of the training as well as the training was recorded. Here's our videographer, and he's pinning a lapel mic on the next trainer. And here's an example of how the training was conducted. Now, all the trainees were watching. They were there. They're just not in this photograph. But the trainer was speaking to the camera, and he had a lapel mic so that his audio was clear. What that means is that when this was edited and saved, now they're going to have a good recording that they can show new hires. They could do it once. Yeah, Melissa has taken the training. They can show as a refresher once a year to their existing employees, and it actually is a meaningful training video.
Yeah, as the owner, this was priceless for us because we normally get an O&M manual. Manual goes on the shelf. Everybody knows where it's at, what it's for. Nobody ever looks at it. But this was an excellent job. So if you have owners, this is something that you might want to consider if you have a job like this, that it's complex, and it's priceless for us.
Right. And remember, you won't get it if you don't get it in the specs. Then we had the O&M manuals, and they're way too big and way too bulky to show, but I just have a few slides of examples. For the refrigeration, now this harkens back to what Melissa was saying about the logistical difficulties of being in Borough. Since almost everything comes by plane, except for a very short window during the summer, then hazmats, hazardous materials, liquids, refrigerant, pressurized gases, even nitrogen is a hazardous material and can't go on a regular airplane. When a contractor mobilizes up in the North Slope, they usually ship extra materials because they know that being one bolt short can cost them $5,000 just in downtime and shipping of getting that material. So this is the leftover materials, refrigeration materials that the refrigeration contractor saved on a shelf in the chiller room. His gases that he used for purging and charging. The O&M manual of the equipment itself was highlighted so that you got a clear indication of which coalescing filter was used. There's a piping diagram of how it all fit together. Likewise, there was a very thorough O&M manual for the PLC, and they included the native programming and all the components that they had in their product. So the building commissioning process applied to a single piece of industrial gas field equipment. We examined the equipment. We went through the owner's project requirements, and we learned something, by the way. Project specifications were developed. We figured out what was needed, like the training, like the O&M manuals, and so they were developed to meet the needs of the owner. We had plans and specs, and I guess I just said that, didn't I? The owner was represented by qualified engineers during all of the upgrades. I can pat myself on the back. Actually, I was just part of the team. There were other very qualified engineers that did a lot more than I did technically. I was really managing the process. And I had an understanding of the technical part, but I felt that my most important role was to manage the process itself. The system underwent a real rigorous FCO and a lot of benchmarking so that the owner really knows what the equipment can do, what it did do when it was new, and if this process is repeated in 5 years, they'll be able to see if it's been degraded or anything like that.
Yeah, even though we are a small gas facility, we still have the same requirements as BP and ConocoPhillips over in the gas field in Prudhoe Bay.
The project was accepted based on verifiable criteria, and of course that was all recorded and it's all saved. And we had a job complete. This is the chiller room. Right over here are those spare refrigeration supplies. They're the 4 compressors. Behind them are the 5 actually, evaporators. And on the back side is the HMI and the electrical panels. Right here you'll see the exhaust fan. These are from the supply fan. This is the fire suppression. Here's all the refrigerant piping going out to the air-cooled condensers. And here are 2 of the 4 coalescing filter system or coalescing separator systems. Our lessons learned were that the building commissioning process can be applied to a non-building application. Get the whole story. Really, you look at a project, you think, I thought it was going to be a chiller. and it was a different chiller than what I thought it was going to be. When I asked more questions, then there were all kinds of new information that came up. Work with the owners, develop your OPRs. That's where you really get to understand what your primary objectives are. And the owners can only expect thorough commissioning if they specify it. It just doesn't happen by itself. It's too big of a process. Something like this was a major project for us, and we're really proud to have been part of it. So with that, I want to say thank you very much for attending. I'd be happy to answer questions if anybody has them now. Yes, right here.
I have a quick question. You mentioned that during the process you ended up basically adding those oil management filters, the separators. You would imagine that would have been something that original design should have had. So I'm wondering, what was the process of finding that out and getting agreement from everyone to add that piece? Was it mostly manufacturer deciding on that, or was it the mechanical engineer, or who was it?
Well, that's
Decided there's something missing.
yeah, that's a super good question. That was the crux of some really difficult times that we went through on this project. When the chiller was specified, they said, hey, give us this chiller, and it was a performance spec. And of course, it was bid. And this supplier custom designed the chiller, and he custom designed it to the specs. Then when they went and installed it, he was up there for startup. He made a long list of things that should be done. But it was running, so they took the long list of things that should be done, they put it in the O&M manual, and they put it on the shelf. Nobody ever looked at it again. A coalescing oil filter was one of those things. When we came back, our refrigeration technician, or mechanic, was looking at it, and he came up with the same recommendation. So we started putting two and two together, and we said, hey, Melissa, I think we're going to have to do this upgrade.
Yeah, as the owner, I mean, it's been a long time since this was in the in the design phase, and as the owner, that was something that we didn't understand that needed to happen for that piece of equipment, and we did not have experienced operators to say, hey, before you check this off, this should be we should have this piece. So yeah, we had no idea.
Okay, yes.
I know now.
In the back.
Melissa, I want to know if
can't hear you.
Amazon delivers to boroughs. Does Amazon deliver to boroughs?
Yes. We have Amazon Prime, and Amazon Prime is the best. So we order everything we can possibly order on Amazon Prime. Yep.
Yes, right here.
How long did the whole process take?
It took about 2 years.
Yeah.
It took about 2 years. We thought it was going to be a quick job over the summer, and then all of a sudden we got slowed down by the next winter, and then some more investigations, and then we had to write RFPs and engage the contractors, and then they had to build their materials, especially the PLC took some time, and so it stretched out about 2 years before it was done. Any other questions? Yes.
It's the same as just regular refrigerant that you would have in a grocery store for
Yep.
freezers and refrigerators.
Yeah,
Actually, yeah, the technician that came up, he maintains our store, and our college has freezers, and our school district refrigerators and freezers, and so he maintains all of that.
It's R404A.
There you go.
R404A, and about that refrigeration company, their website showed them maintaining and working on 7-Eleven refrigerated cases and grocery store refrigerated cases, and we were a little worried at first that they really didn't have this kind of industrial background, but oh boy, these guys were smart. And when we got the manufacturer's engineer and that guy together, I think we had a whole world of knowledge, and they really set it up right. Any other questions? Well, with that, then I want to say thank you so much for attending. It's been our pleasure to be here.
Thank you.